There are four variables that affect rate of reactions, and I'm going to name them first and talk about the first two of them. One is if you increase concentration, and you have to remember this applies to only aqueous chemicals. So if you do that for aqueous, the rate of reaction rate increases. Now for gases, on a rare occasion you might see this. For gases, if you increase pressure, this is also same thing. The rate increases due to that. The other factor is if you increase surface area. This is only for solid chemicals or reactant. You increase the rate goes up. One other thing you should realize, which I'll talk about a little bit more, is surface area increases when the size of the solid decreases. Now these two variables or factors, these are what play with the frequency of collisions. More particles you have in a crowded beaker, you would have more collisions. Frequency of that goes up, the rate goes up. Then there are two other variables left. So one is introduction of a catalyst. If you put a catalyst for a system that works with a catalyst, the rate goes up. And the last one, which is the most important one, is effect of temperature. If temperature increases, that is proportional to increasing your rate. So to talk about the first two, let's go after concentration first. And for the first two, I'm going to give you a typical reaction that you should know. Calcium carbonate plus hydrochloric acid. A solid and an aqueous, giving you calcium chloride plus water plus CO2. Now, if you want to increase the concentration, make sure you go after HCl, the aqueous. So meaning that if you put 2 mole per decimeter cube of HCl, it should be approximately faster than twice as much as fast as 1 mole per decimeter cube of HCl. And to have a picture in mind, so I'm going to say, imagine that the reactants are A's and B's, and in a beaker you have 2 particles of A and 2 particles of B. This is your possible collisions. This A bumps into this B and the other B, and the same thing happens to other A. If you follow the arrows, you see there are 4 possible collisions in order to give you the chemical AB. Now what happens if we increase one of the reactants? Let's say A, we put 3 of those particles, B still 2. Now let's look at the collisions. This A bumps into the 2 B's. The same thing happens to the middle A and finally to the far right A. And now you have 6 possible collisions, so frequency of collisions went up, and therefore you have faster rate of production of AB. So increase the concentration of the aqueous and you increase the rate. Now let's just look at this size and surface area. Same reaction, calcium carbonate, solid plus HCl, aqueous, giving you your products. So what I'm saying is, in order to increase surface area, we are going to make the size of this smaller. So smaller size could be powder, a larger size could be just a chunk. This is fast, extremely fast compared to this. To have a picture in mind, imagine you have a block of calcium carbonate like this, sort of a rectangular prism. Now if I ask you how many sides do you have, how many surfaces do you have, you would say 1, 2, 3, 4, 5, 6. So 6 surfaces or 6 sites of reaction. Now what happens if we cut it in half? So we are decreasing the size. Let's just have it into 2 smaller cubes. If that's the case, you should agree now we have created more surfaces for the reaction to take place. You have 6 plus 6, you have total of 12 surfaces to react. Therefore, the reaction is faster. Fast, slow. Now, then again, I'm going to ask you to remember that in order to increase surface area, size decreases surface area increases. We talk about the other 2 variables that play with the energy on the next slide.